So just a minor update. What I've done is this, so the first cell is the one that's a bit low at the moment right now, and it doesn't seem to be increasing too quickly. So what I did is instead I put this buck converter circuit here to 4.1, and let me just put the there. So you can see the output. Okay, it's saying 4.08, and that's because obviously it's pulling the voltage down. So I'll put it at 4.1 because then it seems to be sitting at 3.9, and the output is calibrated to 4 volts. So if I actually increase it to 4.1, then, because obviously you need a voltage offset to be able to actually put charge in it. That's the idea. And so that's now increasing that. So presumably that will now increase to 4 volts, roughly. And then we can see. So, okay, this is increasing. The other thing I've done is actually added in 2 more decimal places since we have more stability now. And it tends to be that the number of samples that you give, you add those decimal places in. So because we're doing 5,000 samples, then really we can add 2 more, at least 3 more decimal places in to get the accuracy. But I mean, there's a limit on how you can do that. So you can see here, 36, 0, 36, 3.61, and with a bit of luck that should then, I mean it's wrong because of the output, the voltage reading is wrong. So reading at the output of the, obviously, and there's also the problems with these wires which are a bit on they're a bit thin. So, damn it. Yeah. Let me just undo that. I've been switching these around a bit too much. On another one. Yeah. Okay, so I can now put that one onto there. And then we can put that one, sorry if I'm wandering around with the actual shot. So I'll put that one on there and that one on there, which is across the cell, and now we can see it's 3.93. It was on, well, these are pretty stable because they're good cells. I think it was slightly below that. It was like 3.90 or something. I can't remember, to be honest. But we'll probably see it increase. In fact, we've got a 6.2. Yeah, we are. See, now it's saying, if you ignore the last ones, it's 362. In fact, it is 363. It rounds up. Yeah, so that's increasing now, and hopefully that should stabilise at 4 volts. That one's saying 4.04, and that one's saying, this one's actually saying 3.89, but if you actually meter it, it does say 4 volts. So that one has actually charged, which is interesting, and yet this one isn't. I don't know. So we'll see. We're getting pretty close to being balanced, though. You know, we need them all at 4 volts. This one's slightly over. This one's at 4 volts now, and this one's slightly under. So again, obviously the balance is much better because this was 2.5 volts when I first connected it. Now it's 4 volts. This one did charge, but because the pack was charging linearly, this one's actually gone up to about 4.1 volts ish. And this geyser was a bit low. They just simply had different charge levels in them. It's not that this one was degraded, I don't think. Anyway, so the obviously it's manual, but the theory is there. You know, sorry, the practice, the practical side is there. It's just I'm using something rather odd. You know, the isolation transformer, which is actually quite warm. It's interesting. And then we've got the buck converter. Now, normally you wouldn't do it like that. Essentially, you would make a circuit, which was probably much more trivial than this, which was essentially, you know, like some sort of a, you'd incorporate the buck converter into there sort of thing. The only reason why I'm using a buck converter here is because this is just off-the-shelf component that puts out 15 volts. I can't tune that, it's completely sealed. So I've got a buck converter in there to actually convert the voltage down to 4 volts. You see? Yeah, like I say, normally you'd have a small flyback circuit or something like that, which is adjustable. Or it could even be set to a fixed voltage because these cells are fixed. You know, the charge level is fixed, so it wouldn't be beyond reasonable use anyway. So you can see it's actually drawing a little bit more now since I've put that on, and obviously it will because it's drawing the power from the terminals, the same terminals that this is connected to, and it's trying to charge that cell, and it is successfully charging it. So that's obviously working, and it's currently drawing the power essentially from the power pack now. If I was to take out, I left it on overnight. I didn't want to do that, but I did leave it on overnight, and that's why it's now charged at 12 volts, and the current is, milliamps. It was actually, when I first came in, I think it was on like 7, 0.07 on there, which is about 70 milliamps, which is essentially probably what this circuit takes. I don't know. Anyway, excuse me. Yeah. So yeah.